Assalamualaikum everyone, welcome back to my channel Blessed Twinkle. Today we are going to study about the chapter number 6, which is about solids. It's about crystalline solid, different types of solid, different theories, different laws of the solids, and we are going to start short question answers of chapter number 6 solid today. So first question we have is define the following terms: allotropy, sublimation, melting point, and unit cell. These are the four definitions which we have to define in the first question. Make sure to subscribe to my channel and hit the bell icon to get the notification of my every video. Like the video and share it more and more. So we are moving to the first definition, which is allotropy. The first definition is allotropy. Actually, what is it? It is the phenomena in which the same element exists in two or more crystal structure. इसमें एलोट्रॉपी उसे कहते हैं कि कोई भी सेम एलिमेंट, एक ही एलिमेंट डिफरेंट फॉर्म्स में, डिफरेंट क्रिस्टल्स में हमें अरेंज नज़र आए, structured नज़र आए, that is allotropy. Now we have another definition, which is sublimation. We can say that some solids directly change into vapors on heating without passing through a liquid state or a liquid phase, which is known as sublimation. For example, solid carbon dioxide, iodine, camphor are sublime. The third definition we have is melting point. Solid melt on heating up at a particular temperature. At a particular point of the temperature they melt is the melting point of a particular element or a particular solid. The fourth definition we have is unit cell. The smallest repeating pattern from which the lattice is built is known as unit cell. These are the four definitions which we have in question number 1. Now we have the question number 2, which is define anisotropy. Which type of solids have this property? So how you will write the definition of anisotropy is that first of all you will write the definition as anisotropy describes the behavior of crystalline solids in the variation of certain physical properties like electric conduction and refractive index. And then you are going to tell that crystalline solids show anisotropic behavior, that is properties like mechanical strength, refractive index, and electrical conductivity depend upon direction. So question number 2 answer you can write in this way. Now we have the question number 3, which is what is transition temperature? Explain with example. So first of all you are going to write the example definition of the transition temperature, which is you will write in this: transition temperature is a temperature at which both allotropic forms of the same element coexist in equilibrium. The example of transition temperature is found in the allotropic forms of the sulfur. इसमें क्या होता है कि ना ट्रांजिशन टेम्परेचर ऑफ रोम्बिक एंड मोनोक्लिनिक सल्फर का जो है वो है 95.5 सेंटीग्रेड, जिसमें ये दोनों फॉर्म्स एक ही एलिमेंट दैट इज सल्फर को एग्जिस्ट करती हैं इक्विलिब्रियम पर, दैट इज 95.5 सेंटीग्रेड. Now we have question number 4, which is explain why diamond is a non-conductor of electricity and graphite is a conductor. It is a reasoning question and it is a question number 4, so we are going to discuss it right now. The reason for this is that के जो diamond के जो molecules होते हैं टाइटली पैक्ड होते हैं और जो कि ज़्यादा मूवमेंट ऑफ इलेक्ट्रॉन्स अलाउ नहीं करते। लेकिन ग्रेफाइट के जो मूवमेंट मॉलिक्यूल्स होते हैं वो इतने टाइटली पैक नहीं होते, लेकिन उनमें मूवमेंट हो जाती है इलेक्ट्रॉन्स की उनकी लेयर्स के दरमियान। So this is the reason that diamond is a non-conductor of electricity, whereas graphite is a conductor of the electricity. Question number 5 we have is define lattice energy. Explain how it is affected by size and the charge of ion. Lattice energy is energy released when 1 mole of ionic crystal is formed from isolated gaseous ions. And next part of this question, which is explain how it is affected by size and the charge of ion. So we are gonna discuss it right now. So first of all, we are gonna discuss about the lattice energy. Charges decreases with the increase in the size of the ions, cations or anions. The reason in both cases is same. The smaller the size of cation or anion, the closer the packing of the positively charged ions, and thus require high energy to break the lattice and convert the solid ions into isolated ions. For example, we have lattice energy of sodium fluoride. We have 923 kilojoule per mole and is higher than potassium fluoride. Because of smaller ionic radii of sodium and potassium ion, the smaller ionic size of potassium ion makes the packaging more closely and thus need relatively high lattice energy for the separation of the ions. And now we are gonna tell about lattice energy is how it is affected by the size by the charge of ion. Lattice energy is also affected by the charge of ion. The greater the charge of ion, the higher is the lattice energy. For example, we have BeF2. The lattice energy for this is 3505 kilojoule per mole, is much bigger than LiF1, which is 1036, because lithium possesses positive 1 charge in lithium fluoride, whereas the charge of beryllium is positive 2 in beryllium fluoride. So this is the affection of the lattice energy by the size of the ions and the charge of ion. Now we have question number 6. इसमें differentiate है crystalline और amorphous solids की और isomorphism और polymorphism के दरमियान differences हैं. इनका difference लिखा हुआ है, you can read it, and if anything is not clear here, so you can ask me in the comment section. Okay. Now question 7 we have, उसमें हमारे पास 2 reasonings हैं. एक है why the compressibility of the solid is nearly zero, और इसका आंसर ये लिखा हुआ है, you can read it from here. And second reason जो है वो है why some solids are sublime in nature, उनकी sublimation की वजह से वो sublime होते हैं. You can read that answer also from here. Okay.